Okay guys, this is our video for our touch receptors, or our touch and pressure receptors, because they're you can refer to it as just a touch receptor, but it also senses pressure, which is also the sense of touch. So before we get into the different types of touch and pressure receptors that we find in the integumentary system, we need to think of a couple of concepts. The first concept is the idea of a fine touch and pressure receptor versus a crude touch and pressure receptor. And it all has to do with the size of the receptive field. So a receptive field is the area around a pressure receptor or a touch receptor that receptor will respond to. So the area around a receptor, specifically a touch receptor, that the receptor can sense a stimulus within. So if you touch the skin within that receptive field of that specific receptor that we're talking about, then that receptor will fire or have an action potential, respond to that stimulus. If you touch outside of the receptive field, that receptor will not fire, it will not have an action potential. So for a fine touch and pressure receptor, that's going to have a really small receptive field. So you have to touch it very, very close to where it is. So here I've drawn 4 little touch and pressure receptors. Those would be the little dots in the center. And then the little circles around them would be their receptive field. So let's just draw one from scratch. So there's the receptor. Here's the receptive field. So as long as I touch anywhere within that receptive field, that receptor will fire. And this is very, very tiny. Even in this picture, I haven't drawn it small enough to really represent just how small the receptive field for a fine touch and pressure receptor is. Now if I touch way out here, or even just outside of that receptive field, that receptor is not going to fire. It would be another one that would be nearby. And that's usual for fine touch and pressure receptors. They'll be very close together so that their receptive fields overlap a little bit. Whether we're talking about fine or crude ones, the receptive fields will be right up against each other, even overlapping. We'll skip the second part while we get into crude, and then we'll get down to the second part. But for the crude touch and pressure receptors, they have a very large receptive field. So here's the receptor right there, and then here's this great big receptive field. And I've exaggerated how big it would really be in the human body, but just so you get the idea, if I touch, right next to it, this fires. If I touch way far away from it, over here, this fires. So you get this really large area that this one little receptor is monitoring, where with the fine, you have this little tiny area for this receptor to monitor. So what happens then is, when you are using fine touch receptors, so in areas where you have fine touch receptors, you can be really specific in locating a stimulus. So you know exactly where you were touched. So think about your fingertips. Lots and lots of fine touch receptors there. And if you're to take like a little tiny pin or something and just kind of poke on your fingertip, you know exactly where that touched you on your fingertip. You can really pinpoint it because it's got just this little tiny area. And remember, this is an exaggeration of the size actually. So it would really be like that little tiny thing. So you know right there, that within that millimeter, you touched right there. With a crude touch and pressure receptor, you don't really know exactly, like it could be here. It could have been over here. So you have a bit of a space there, this kind of, large area of possibility from where that touch could happen. So if you think of, say, your back, where you'd have more crude touch receptors, think of, when you get that itch on your back, but you don't know exactly where it is, like you think you got it, but it feels like it's kind of running away from you. That's because this receptor is firing. The itch is maybe here, but you don't know. It could be here or here, 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 anywhere within there. So that's the difference. Not quite as specific in terms of where something is originating from. Okay, so using the word specific again, specificity. This is dealing with what kind of stimulus the receptor is going to be able to respond to. Some receptors are very specific about what stimulus they can respond to. So they may only respond to touch, or they may only respond to a very specific, a very particular kind of touch. Like it might be a texture change that they can respond to, or a stretch of the skin. Other receptors are not quite as specific. And the specificity has a lot to do with whether the receptor is just kind of hanging out there, which we'll see some that just, they don't really have much structure around it. Others will have a structure around it called a connective tissue capsule, and we would call that an encapsulated receptor. And that, it doesn't necessarily make it more specific, but it does help to make it more specific, and also tends to make it a little bit less sensitive. If it's unencapsulated, that's going to be something that might tend to make it more sensitive to stimulus, and also maybe a little bit less specific. Not necessarily, but just generally these are factors that can play into that. And then the final thing that we need to think about before we get into the examples of our touch and pressure receptors that we find in the skin is the idea of adaptation. And adaptation is when a receptor stops responding to a repeated stimulus. So you have the same stimulus over and over again, and eventually the receptor just disregards it. It stops firing an action potential. So if you think of, like you just kind of touch your skin, and you kind of keep touching, and you keep doing that, and after a while, it doesn't feel quite as much. It's maybe even a little annoying if you just keep doing that. That would be adaptation. Or probably a better example would be when you put your clothes on. You put your clothes on, you feel your clothes going on, but then you don't walk around all day noticing your clothes touching your skin. They're still touching your skin, but you're not feeling it anymore. You can if you start thinking about it, which you probably are now, but you're not necessarily, noticing that stimulus anymore. That's adaptation. So those receptors that are responsible for noticing, say, the clothes going on your skin, that really fine touch, that really light touch, they would be called fast adapting because they adapt very quickly. That just means that they're going to stop responding to a stimulus really, really fast. But you can also have a slow adapting, which means it doesn't adapt at all. So no adaptation, or the adaptation is just, not going to happen very, very soon. So it'll take a while. So unfortunately, things like pain receptors tend to be slow adapting. They won't adapt. They'll just keep telling you that you have a painful stimulus. Okay, so for our examples, I've divided them just into two categories, the fine touch and pressure receptors and the crude touch and pressure receptors. So small receptive field, large receptive field. So I'll just go through our 5 examples one by one. So first we'll start with the fine touch and pressure receptors, our free nerve endings. These are exactly what they sound like. They are just the end of a nerve. They are something called the dendrites of a nerve, which we're going to learn about in a later section, but no harm in learning that word now. That dendrite acts as a receptor for a neuron. And in the case of a free nerve ending, you just have these dendrites just sitting there with no capsule around them. They're just kind of exposed to whatever stimulus is happening. Now, these can be fast or slow to adapt depending on where they are. I'll explain that in a second. They're polymodal. This means that they are not specific. They will respond to anything. So they can respond to touch, pressure, pain, temperature, all sorts of things. An example of where you find free nerve endings would be in your tooth sockets, so where your teeth are. And normally there would be a tooth filling that tooth socket, and there's, like kind of the pulp inside the tooth, and there is a nerve ending inside of that pulp. And if you've ever had a toothache, you'll know that, if you put pressure on that tooth, it hurts. If you drink something cold and it gets on that tooth, it hurts. Something hot gets on that tooth, it hurts. So anything triggers that free nerve ending that is in the pulp of that tooth. So that is going to be an example.